This is 2.2a, College Algebra, page 193. And in 2.2, what we're doing here is getting started on complex numbers. And if you've had Algebra 2 or intermediate algebra, you already are familiar with complex numbers, which is basically just the square root of -1 is not a real number, because there's no such number that we can take x squared and get a -1 or any negative number. So whenever this is the case, what we end up with is a graph that does not cross the x-axis. So for instance, f of x equals x squared plus 1. And if we were to set this equal to 0, we would get x squared equals -1, or x equals plus or minus the square root of -1. And since there is no number, that just means that the graph does not cross the x-axis. So there are no real number solutions for our y value when x equals the square root of -1. And if you remember from back in the olden days, we use the symbol lowercase I to represent the square root of -1. We also use I squared to represent -1. And if you think way back, I cubed equals -I, because I squared times I equals -1 times the square root of -I, and we already know the square root of -I is I, so that gives us -I. And I to the 4th power just equals 1, because again, I squared times I squared is -1 times -1, which is +1. So remember what those are. Write them in your book, write them on your forehead, write them on your hand, write them somewhere so you can remember to use those later on. Alright, so when you're going to express a number in terms of I, what you're going to do is you're just going to take a -1 out, or just the negative out, and it becomes I, and everything else stays in there. The correct way of doing this, I mean, I like to write it as I squared is 7, but the correct way is actually 7 and then I, with the I not under the radical. But I don't like writing it this way, because if this extends too far, even though it isn't supposed to be under the radical, sometimes it looks like it. But that's the way the math world does it, so we'll kind of stick with that. Now if we have something like the square root of -16, we can just take the square root of 16 and stick an I on it, because there's a negative, and that negative just represents I. So 4I. Or if you have negative the square root of -13, you're going to bring out an I and leave the 13 in right there. And then again, because the book does it this way, we'll try to play according to their rules. Okay? So that's about it as far as that part. Well, let's try this one. The square root of -48. If you remember, you're breaking things down. The square root of 48 is actually the square root of 16 times 3. So we can bring out a 4 and get 4I square root of 3, or 4 square root of 3I. Now this one in particular, they have or. They said you could use either or that. I guess all of them, they give you that option to put the I in front, unless it's something like this. No radical sign, just leave it as 4I. So complex numbers, bottom of page 194, tells you the format, or the standard notation for writing complex numbers, and they want them written as A plus BI, which means they want the number and then the I followed with a plus sign. So note that either A or B can be 0. So if we wanted to write the number 3, that would be 3 plus 0I. If we wanted to write that in the form that they're asking you to put in there. I don't know if there's a name for this form. They just say a complex number is a number of the form a plus bi. It could be that your a is 0, so it could be 0 plus 4i. Well, in this one you get 3, in this one you get 4i. So it's still written in this form, it's just the a or the b can be equal to 0. Alright, so let's keep chugging along here. Bottom of page 195 gives you addition and subtraction, where they have things like 8 plus 6i, and then they're adding 3 plus 2i. Nothing really weird about this. You just do the work as if I were a variable. So you'd add your constants, and then you'd add your imaginary part or your complex part. Same thing with subtraction, 4 plus 5i, and then let's say we're subtracting 6 minus 3i. And when we have a minus sign, I always just like to take the parentheses off first just to make sure I distribute that minus sign, and then I can go 4 minus 6 is negative 2 plus 8i, and I'm done. Now remember, keep it in that form because you want to keep it in a plus bi. Multiplication should be real quick and easy. If we were to multiply square root of negative 16 times the square root of negative 25, what I do is I just immediately take out the i's. Oops, 25. And then take the square root and then add those together. I don't add those together, I multiply those. So make sure that's a multiplication sign. Was doing addition in the last one, so you get 20i here. Actually squared, and then 20, and I squared we learned earlier is negative 1, so that gives you negative 20. Okay, so hopefully I can keep you from getting too confused because you get talking and reading and all that at the same time. 1 plus 2i. We're going to use the FOIL method for this one, so just your regular first, outside, inside, last, don't forget to square the I, so 1 plus 5i minus 6. And then when we do the subtraction, minus 5 plus 5i, and remember the constant goes first. Okay. So if you remember in that, when I gave you that table with all the i's, I1 to I to the 4th power, that's where we get to an example 4 on top of page 197. You have I to the 37th power. Remember what I've told you to do? Take the exponent, divide it by 4. And all you care about is the remainder. So I divided by 4, or 37 divided by 4 is 9, and we have 1 left over. So our answer to that then would be I. All we care about is the remainder. You divide by 4, get the remainder. I to the 75th power. And this is not the way the book does it. So don't count on the book to be showing you how to do this. So 75 divided by 4. So all you're going to do is do your division here. 18, 32, and we have 3 left over. So this is the same as I cubed, which gives me a negative I for my answer. Okay, if I have I to the 80, that has a remainder, because it goes into it 20 times, of 0. And so therefore our remainder is 0, which means our exponent is 0. And anytime you have an exponent of 0, it's always 1. It's not I. So just remember that if you get a number that 4 goes into evenly. Okay, one more short section, middle of page 197, conjugates and division. So the conjugate of a complex number, so we have a plus bi, and its conjugate would be a minus bi. When you multiply those together, your middle terms disappear, so your FOIL, your o and your I disappear, and you're just left with your first and your last. So 5 plus 7i, and we're going to multiply that, 5 minus 7i, and all you have to do is square the first term and square the second term with a minus sign between, and you remember that 49 or I squared is negative 1, so you get 25 plus 49, and that gives you 74 when you multiply these two together. Same thing with 8i. If you multiply 8i times negative 8i, you get a negative 64 I squared, and you know I squared is negative 1, so you get a positive 64. Negative 64 times negative 1 is positive 64. Alright, so if they want you to do something like the example on the top of page 198, they give you divide 2 minus 5i, and they want you to divide that by 1 minus 6i. So we're going to multiply by a conjugate of the denominator, and what that does is it gets rid of your imaginary number, because that's one of the things you want to do. It's just like you get rid of the radical in the denominator, we want to get rid of the I in the denominator. So we use FOIL on the top and multiply those together, and we get 2 plus 7i minus 30i squared. And on the bottom, square the first term minus square the second term, and then we can go from there and get 2 plus 7i plus 30, because our I squared is negative 1, and negative 1 times negative 30 is positive 30. Same thing here, 1 plus 36, so we end up with 32 plus 7i over 37. And we're not done yet, because this is not in the a plus bi format. So we're going to write it as 32 over 37 plus 7 over 37i. So we have to separate into a plus bi in order to be written correctly. Okay, that's 2.2. Completely. That's A. There's no B. You are done.